In this video we are continuing with Geometry Section 12.2. We're looking at application problems. So as I recommended in the last video, anytime you're working with some application problems, it's always a good idea to read the problem several times and also maybe to highlight or circle or underline the important information. So this problem is probably one of the most difficult application problems that you might see in this course, but let's go ahead and get started with it. We have Mr. Chung is standing some distance from the base of a building. The angle of elevation to the top is 65 degrees, so angle of elevation 65 degrees. If he moves 20 feet farther from the base of the building, the new angle of elevation is 54 degrees. So we have a new angle of elevation after he moves 20 feet farther. How tall is the building? So let's go ahead and start with a picture again. So we've got our building, and here's our ground. And Mr. Chung starts out standing here, and to the top of the building we have an angle of elevation of 65 degrees. Alright, and that's really all we know in this right triangle. So he's standing some distance away from the building, and we know the building is a certain height, so we'll label those X and Y. So now he moves 20 feet farther, so here's his new position, and his new angle of elevation is 54 degrees. So I have another big right triangle here. This is 20 feet. So I'm going to draw these two triangles separately. So I'm going to start with this triangle. I have this triangle here. So let's draw that one. This is our original triangle. I've got 65 degrees. Here's Y. Here's my right angle, and that's X. And then I'm going to draw this triangle here. So here's my 54 degrees. This is still Y, but now this whole bottom leg here, it's an X and a 20, so it's going to be X plus 20. So here's my two right triangles. So if you remember from algebra, when you have two things that you don't know, when you have two variables, you're going to need two equations to solve that. So that's what we're going to do. We're going to set up a system and solve it, and we'll figure out the height of the building. Let me just highlight these. This is our yellow, and this is our green, so it matches. Alright, so let's start with the yellow triangle. I have my opposite side and my adjacent side, so that's going to be tangent. So I have tangent of 65 is equal to Y over X. And then let's go to our green triangle. Again, I have the opposite and the adjacent. So I've got tan 54 degrees is equal to opposite Y over the adjacent, which is X plus 20. So we've got these two equations. We have to figure out how to solve it. I'm going to go ahead and plug tan 65 into my calculator and tan 54. We could work with these throughout the whole problem, but I think it'll be a little bit easier if we just work with them the way they are. So this equation here, tangent of 65 is 2.1445 is equal to Y over X. And over here, tan 54 is 1.3764 is equal to Y over X plus 20. So let's see, I'm going to solve this equation for Y. So let's put this over 1, and then I'm going to cross multiply. So I have 1 times Y is Y, and then 2.1445 times X, that's 2.1445X. And now that I know what Y is, here's Y, and here's Y. So I'm going to take all of this, and I'm going to substitute it in for Y. So I end up with, so let's do the substitution down here. I have 1.3764 is equal to, so then y was equal to 2.1445x over x plus 20. Right, so I have another proportion. If I put this over 1, I'm going to cross multiply again. So I have 1 times all of this stuff, so that gives me 2.1445x. Then I'm going to multiply these two. Notice my use of parentheses here. 1.3764 times x plus 20, because I'm going to have to distribute here. So this, again, this is probably the most difficult type of problem we'll do in this section. So pause and rewind as needed. If you happen to be watching in class, feel free to ask questions as you go. Okay, so our next step is to distribute. So I have 2.1445x is equal to 1.3764x. So that's 1.3764 times x. Now I'll do 1.3764 times 20. So that's going to be plus 27.528. Alright, I'm going to subtract 1.3764x. The rest is just algebra here. 1.3764x. So these cancel out, and I end up with 0.7681x is equal to 27.528. I'll divide each side by 0.7681. 0.7681. So those cancel. And I'm left with x is equal to 35.84 feet. All right, so that tells me how far he was originally standing from the building. And now I can use my x to find the height of the building. So really, we can go back to any of these equations up at the top. I can go back to any of these equations up here. This one would be the best one to go back to, because all I have to do is substitute in x and it will tell me y. So I'm going to use that one. So now y is going to be 2.1445 times 35.84, and that's going to give me 76.9 feet. All right, and there's the height of your building. Okay, so again, this is a difficult problem. We're going to set up two equations with two variables, solve it, and we'll get our answer. Again, maybe you want to go through this one more time, make sure you're asking questions, and we'll see you next time.